Well, let's take a look at some basic electrical principles. Now you may think, gee, I've already passed the A6 electrical, I passed A8, I couldn't be here taking this L1 test if I haven't had my A8 engine performance test already. You'd be surprised how many technicians are eligible, take the L1, and have problems passing the L1 because of basic electronic skill knowledge. Either you never learned it the correct way with fundamentals, or you've forgotten some things in your years of wrenching. So let's do a quick review and talk about basic circuits, series, parallel, loads, conductors, power sources, Ohm's law, the essential things that really, once you have those down pat, all the other complex things kind of fall into place. Complete circuit. A complete circuit consists of the power source, in this case a 12-volt battery, a load, a light, and some conductors to send the power into the load and also have the power returned back to the battery. That's called a complete circuit. There's a path for the voltage from the battery to go through the bulb and back to the battery. If we don't have that path, that bulb doesn't light up. In this case, the bulb's lit up, it's a complete circuit. So get that term down straight, complete circuit. Now, we have a picture of a typical incomplete circuit. The wires come off the battery, there's a break in the wire, an open circuit or incomplete circuit are essentially the same. The light bulb's not going to power up because even though I have a good power source from my battery to the light bulb, I don't have a ground coming back from the light bulb to the battery. It stops right here. Unless we're talking 20,000 volts from an ignition system, it's not going to jump that gap. So I have an open circuit. The voltage at the head at the light bulb is 12 volts if we're measured between battery negative, and either side of the light we'll see 12 volts. But when I connect this back again, like we've seen in the previous picture, figure 1-2, we connect it back again. Now this side becomes 0 volts. It's the same as ground if you're measuring between ground or negative and the positive. So complete circuits and open circuits. Here's a complete circuit if we push the switch for the horn. Right now it's an open circuit. We have our power source, the battery. We have our load, in this case the horn. We have our conductors, wiring, connections, and so forth. And we have a switch that if we close this switch, close that right there, we're going to have power flowing from the battery over here through the switch to the horn and back to the battery. A complete circuit, the horn blows. Now, what could cause the horn not to blow? Well, obviously if we open that switch again, the horn's going to shut off, or if the switch was closed and we had, in this next figure, not in your book, a short circuit, then we're not going to have power flowing through the horn. What will happen is, and what's not in this picture, you need in every circuit, is a protection device. Ohm's law involves looking at what the current flow is going to be under a certain amount of resistance. Every load has some resistance. In the case of this horn, it's going to be X number of ohms or resistance to current flow. If we have 0 ohms of resistance, current flow is unlimited, whatever the battery can supply. More on Ohm's law in a minute. So if our switch was closed and we had a short circuit, think of short circuit like shortcut. We had something pinching the wire here that's ground, and the wire on the positive side touching together, pinched with maybe a screw running through a harness where both wires are present, or maybe the horn itself was shorted internally. Whatever the case may be, if there's no resistance in this side of the circuit, if it's strictly 0 ohms or something very small, like less than an ohm or half an ohm or something, we're going to have more current flow than the protection device will allow to flow. In that case, we usually would have a fuse, something that looks like this, schematically. And its job is to melt in half without causing a fire, creating an open circuit, protecting the flow of current being excessive, causing heat buildup and possible melting of the insulation, even a fire in the engine compartment or under the dash, wherever the circuit is. So that's a short circuit. So know your opens, completes, and short circuits. Make sure you're really familiar with those terms, or if you have been, you forgot. They're going to be wording things like that on the test, so make sure you know what they're talking about. You may know what you're talking about, but make sure you know how they may write the test. Okay, next picture. Basic Ohm's law. Now, I read in a trade magazine some time ago that a writer wrote in and said Ohm's law never fixed a car, and one of the technical editors amened it. Said, that's right, Ohm's law never fixed a car. You know what? I'll agree with that in a technical sense. This picture, called Ohm's law, never jumped off a piece of paper, ran to the Snap-on toolbox, grabbed some wrenches, and went out and fixed a car. Never happened, never will. But the knowledge of Ohm's law in your head will help you fix cars. It has me for decades. Knowing how the relationships between amps, ohms, and volts work helps you diagnose things much more quickly. Now, let's explain what it all means. V for voltage. Now, in a regular Ohm's law chart that's non-automotive, we might actually see E for the voltage. E stands for electromotive force, but for the sake of this program, we're going to keep it with automotive terms, voltage. And the I, you might also see I in some electrical training programs. I get my I to work here. Stands for intensity, same thing as amperage, current measured in amperes. And then the R is always still R for resistance, measured in ohms, where we get that Greek letter omega. So the ohms of resistance is R, the current flow, sometimes called intensity, is our A, amperage, and the V for voltage. And basically, all you have to do to know Ohm's law is to remember that the voltage is always on top and amps and ohms are on the bottom. And just like any math problem, if you know two of the variables, the third variable you can solve with simple mathematics. For example, if I know the voltage is 12 volts and the resistance of a solenoid is 12 ohms, 12 divided by 12, 12 volts divided by 12 ohms equals 1. 12 divided by 1 equals 1. 12 divided by 12 equals 1. So the current flow in that 12 ohm solenoid would be 1 amp. If I knew the if I knew the amps and the ohms, if I had 1 amp of current and I knew I had 12 ohms of resistance, I would know that we had 12 volts of supply. So you just know two of the equations, and the third one is done either by multiplying or dividing. That's simple. If you just burn that into memory, and there's not a whole lot of things you have to burn into memory in this business, it's a few fundamentals, and then knowing where to get information, and experience is a big help as well. But that's basic Ohm's law. Make sure you know it thoroughly when you go take an L1 test.